In part A, we are given that A equals 2 centimeter, B equals 3 centimeter, and theta increases at the rate of zero point 0.2 radians per minute, which I have written as d theta over dt. And we want to find the rate at which area changes when theta equals pi by 3. So from the given information, we can understand that only theta increases or changes with respect to time, whereas a and b remains constant. So we will differentiate this area function with respect to time, that is dA over dt. Uh, and when we do that, we have to keep the a and b as constant. So therefore, this half ab will be constant, and then differentiate only sine theta with respect to time. So when you differentiate sine theta, it is cosine theta, and then use the chain rule to differentiate theta with respect to time, which is d theta over dt. Now let's plug the values of a, b, theta as well as d theta over dt so that we determine dA over dt. And so this equals half of a is 2 centimeter and b is 3 centimeter. And then we put cosine of, replace theta by pi by 3, and d theta by dt is zero point 0.2. So we will multiply these quantities. We can cancel this 2 and this 2. And here we have 3 times of cosine pi by 3. Pi by 3 in terms of degrees, it's equal to 60 degree. And cosine 60 degree equals half. So we replace cosine pi by 3 by half times zero point 0.2. And so this equals 3 times zero point 0.2 divided by 2 equals zero point 0.3. And so this is the rate at which the area changes using the given information. In part B, we are given that B and theta changes at the rate of 1.5 centimeter per minute. This is how the B changes, and theta changes at the rate of zero point 0.2 radians per minute. And we want to find the rate at which the area changes. So from the given information, since only B and theta changes here, we consider that A is fixed. So when we differentiate this area with respect to time, we consider A as fixed and find the derivative of other two, that is P and theta. So let's write dA by dt, and this equals, we should consider A as constant. So therefore, you will write half A. And then we have to apply the product rule to differentiate b sine theta because these two quantities changes. So when we apply the product rule, first I write the b and then differentiate sine theta with respect to time, which is cosine theta times d theta over dt using the chain rule. Now I write the second one, that is sine theta, and then differentiate b with respect to time, that is db over dt. Now let's plug in the values which are given. So I plug in A equals 2, and this is multiplied with B is 3 times cosine, replace theta by pi by 3. So it becomes cosine pi by 3. D theta by dt is zero point 0.2 plus sine pi by 3 times dB by dt is given as 1.5. So let's evaluate this. You can cancel this 2 and this 2. And so this becomes 3 times of, we already found cosine pi by 3 is cosine 60, which is half times zero point 0.2 plus sine pi by 3 is root 3 over 2 times 1.5. And so we plug this expression using the calculator, and when we do that, we approximately get 1.6. And so this is the rate at which the area changes. In part C, we observe that all the three quantities, that is A, B, and theta changes That is, A increases at the rate of 2.5 centimeter per minute, B increases at the rate of 1.5 centimeter per minute, and this one is per minute, and theta increases at the rate of zero point 0.2 radians per minute, which means we have to consider that all the three quantities are changing. So when we differentiate A with respect to time, that is the dA over dt, we put this half, and we have to consider the product rule of differentiation. So first we will consider this as a first term, and then sine theta as the second term, and then apply the product rule. So it's going to be, I write down the AB first, multiplied with the derivative of sine theta, which is cosine theta times d theta over dt, plus now I put the sine theta and then multiplied with the derivative of AB. So when we find the derivative of AB, we should apply the product rule to find the derivative of AB, since both are changing. So according to the product rule, I write first A and then multiply with the derivative of B, which is dB by dt, plus then I put B and then multiply with the derivative of A with respect to time, which is dA over dt. So this is the expression when you find the derivative of AB, which I write here. So this is A times of dB over dt plus B times of dA over dt. Now let's plug in all the values. So this becomes a half of A equals 2 and B equal to 3. This is 2, this one is 3, and cosine of theta is pi by 3 times d theta by dt is zero point 0.2 plus sine pi by 3, and this multiplied with A, which is 2, and dB by dt is 1.5 plus B equals 3 times dA by dt is 2.5, and so this equals half. This is 2 times 3 is 6. Cosine pi by 3 is 1 by 2 times zero point 0.2 plus sine pi by 3 is root 3 over 2. And this is multiplied with 2 times 1.5 is 3 plus 3 times 2.5 is 7.5. So let's simplify this. So this gives half times, we reduce this to 3. 3 times zero point 0.2 is zero point 0.6 plus root 3 by 2 times 3 plus 7.5 is 10.5. This equals, we can now plug this expression into the calculator and find its numerical value, which is approximately 4.84. It's 4.85. So this is rounded to two decimal places. So therefore we say that the area increases at the rate of 4.85.